My question to you guys is,
What is
if I take any two natural numbers, let's say natural number 1 and plus natural number 2, any arbitrary two natural numbers, will it give me a natural number? This is my question. Will this number be a are incomplete? Okay. So we can extend this idea, this notion of numbers to something known as integers. We can extend our number line, which was just a second. Yeah, this was our usual number line 0, 1, 2, and so on. But since we have figured out a method to generate numbers which are not in this line, we can extend this notion and make a new dimension in this, which is negative numbers -1, -2, -3, and so on. You are getting this, right? Okay, minus is settled. So now given, okay, these are known as integers now. Okay, so my question is, given any two integers, integer number 1 plus integer number 2, are we getting a integer? Same question, but for integers.
Yes.
Yes, sir, because the product of any negative or positive numbers will still be integers, sir.
Exactly. We will be getting integer if we add any two arbitrary integers. Okay, this addition is sorted. This was already sorted in natural numbers also, but okay, let's just move forward. And what about negative? Now this is the problem we solved in natural numbers. The problem with natural numbers was, given any two arbitrary natural numbers, if we subtract them, it is not necessarily that we will be getting a natural number. But since we have extended our domain to integers, this problem is solved. What about multiplication? Given any two integers, if we multiply them, are we getting an integer? If we change this sign of plus to multiplication, are we getting an integer?
Yes, sir.
Exactly. But if we do division, are we getting an integer?
So not necessarily, so we can have fractional
We can
numbers
have
also.
decimals. Exactly. So this motivates us. Division. Division motivates us to extend our notion of integers to something known as rational numbers. Okay.
Yes, sir.
So if this is clear, let me just erase this and write it in a more clear way. Okay. So subtraction. Subtraction. This motivated us. Oh, wait a minute. Uh, Subtraction. This motivated us to go from natural to integers. Okay. And division. This motivated us to go from integers to real numbers, rational numbers. And I am writing rationals as rational and integers as I because there is a reason. There are they have symbols. Okay, so the set of natural numbers. I will be getting what is a set in a while, in maybe next class. But let's just say a group. Okay, a circle in which an island where every natural number lives like 1, 2, 3, and so on. Then let's just say this is a set for now. A group. So the group of natural numbers is referred with this symbol, with uh, this this a slightly bold diagonal line. This symbol represents natural numbers. Okay, integers integers are referred with this Z symbol with this diagonal a little bolded. Rationals rationals are represented by this Q uh, with a little boldness in some this areas. Okay, rational is represented by Q, and then there is something known as a real number, which is represented by R, and we will be getting to reals very soon. Okay, so we did subtraction, we got integers. We did division, and we got what we got? We got rationals. What else? What else we can do? You guys suggest any operation which we can do to extend our domain. Any operation. Let's. We are in rational phase right now. We need to go to reals. Suggest some operations. Any operation. Okay. Never mind. I will do something. So let's just say we have a triangle. We have a right angle triangle of side length 1. Okay. Now my question to you is, what is this length? This length.
Hypotenuse, sir.
Yeah, that is hypotenuse. That is correct. But what is in numerical terms? What is this length?
So it will be 2 by a square plus b square equals to c square.
This is square root of 2.
Yeah,
And the square root of 2 is an irrational number.
yeah.
We all know that. So there exist infinitely many irrational numbers, which creates hole, which creates blind spot in our number line of rationals. Number line of rationals. So this is our normal number line. Okay, this is one, and let's just extend this number line in this direction as well. And this is one. Okay, just a second. Uh, are you guys comfortable in English, or I should do bilingual? Okay, I will do bilingual then. Okay, we have this length as one. We have this length as one. We got this length as a square root of 2. If we draw a circle from this, and if we draw this circle, then this length will be square root of 2. ठीक है, ये लेंथ भी अपनी स्क्वायर रूट ऑफ 2 है. Now this is the place where the hole was existing in our previous number line, in our rationals number line, and we can prove that square root of 2 is an irrational number. But I will not be proving this right now because we will do first operations and then we can come here. Is it correct? Are you guys okay with it?
Yes, sir.
Okay. So let's just review what we have done till now. We had some numbers. We had natural numbers. We had an island of natural numbers. We extended this island and we got integers. Please note these symbols. These symbols will be important. These symbols come in very handy when writing sets. Okay, so we had natural numbers. We extended it to integers. We extended our integers to rational numbers, q. Okay, and then we extended our q with something known as uh, I'm getting a bit lack in space, but okay. This is real numbers. Okay, you can see how one is inside another. एक दूसरे के अंदर में है. This is inside this. This is inside this. This is inside this. Okay. Now let's just review some operations which we performed a little bit earlier. Let's start with multiplication. Can you guys tell what essentially is multiplication? What is multiplication in its essence? Like, what is multiplication? When I say 2 times 3, let's just say, what 2 times 3 actually means?
So repeating 2 3 times, leading to basically like multiples of 2 and 3.
Exactly. So, like, if I have this box, I have these two boxes, okay, and I make copies of it. If I can make, okay, Control D. This is one copy, this is second copy, and this is third copy. Copy of 2 3 times. We got 6 copies essentially. Finally, this is this is what we refer to as multiplication. And if we introduce decimals in it, like 1.5 times 2, let's just say, then this essentially means cutting in half this box. So this is one box, and this is half box, 1.5 box, and we multiply this by 2. We got another box here, and we can complete this half, and we got 3 boxes. This is essentially multiplication. So multiplication in its essence is repeated addition. Okay, multiplication in its essence is repeated addition. Repeated addition. We added 2, we again added 2, we again added 2. We did this process 3 times. We got 6. Is it clear?
Yes, sir.
Okay. So multiplication in its essence is repeated addition. So we can generalize this. We can generalize this notion of any m times n is equal to m plus dot 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 plus m, and we will doing this. We will be doing this process for n times. Okay.
Yes, sir.
And there are some notations here which might come in handy in some textbooks. M cross n is m dot n and mn. These are some notations. Okay. When you will be studying some further mathematics like some vector and all, this dot becomes some different thing, and sometimes it might cause confusion. So I'm just stating this, so you can refer to them back and forth. This should not cause any problem. And there are some rules associated with multiplication. These are not rules essentially. These are some properties with which come. So if I do minus m times n, this is essentially negative 1 times m times n. This is our usual m cross n, and we do a minus 1 multiplication. Okay.
Yes, sir.
And we all know this m cross m is known as m squared, and any m cross m or any n times is known as m to the power n. We have all studied this. So this was multiplication. Let's come to division. Now, as I stated in multiplication, that multiplication is repeated addition. Now, my question to you is, how can we describe division? What is division in its essence?
So dividing a certain number by a given certain number of times. So
Yeah, that is true. But my question is, what essentially is division? Like, what are we doing when we're dividing something? Okay, let's take an example. We have we have this length. Okay, let's say we have this rope. This is a rope. Okay, and I have this length. I have this length. Oh, let me just make it a little. Okay, I have this length. Okay, my question to you is, how many pieces of this rope I can make out of of this length? Okay, let's try to make some. Uh, and here, okay. So let's take a knife and or a scissor maybe and cut this rope. This is the first piece of this length. This is the second piece. This is the third piece. This is the fourth piece, fifth piece, sixth piece, seventh piece, and this is not quite of the same length. Okay, so we will come to this a bit later. Let's come to this piece a little bit later. But okay, so we got one piece, two, three, four, five, six, and seven pieces of this length. Okay, so what we are doing essentially is we are subtracting length. This was our original length. We subtracted this much. Then we again subtracted this much. Then we again subtracted this much. We did this process until here, and we cannot subtract this number anymore because this is smaller. We cannot make a piece out of it. Okay, this is essentially asking dividing a pizza among three people with two slices. I can't do this. I can give this slice to one person. I can give this slice to another person. But basically, I need to make separate pieces. I will need to make more cuts in it. But yeah, that is quite the thing. So there are some terminologies associated with this cutting and chopping and all. And this cutting of pieces of multiple lengths is wait a second, my pen. Okay, so this is known as quotient. This is known as quotient. QUOTIENT. If I just spelled it correctly, I don't know, but okay. This is known as quotient. How many pieces we made? So we made one, two, three, four, five, six, and seven pieces. And after making those seven equal length pieces, we got this extra chunk. This extra chunk is known as remainder. Okay. So let's do this numerically. Okay. Let's do this a little bit numerically instead of visualizing it with ropes and all. Let's divide 15 by 2. Okay. So we know this is 7.5, but let's just not do zero point 0.5 and all. Let's try to make some chunks like this. First, make a chunk of 2. Again, make a chunk of 2. Again, make a chunk of 2. We will make such chunks up till 7. So this will give us 14 plus a chunk of 1. This is the quotient part which we talked about. And this 1 is the remainder. So can you guys see how division is essentially repeated subtraction?
Yes, sir.
Okay. So this was about division, and there are some terminologies, more terminologies associated with division. Let me tell them quickly. So one is mod, like there are some operations. Okay, these are some operations essentially. So B mod A is equal to some number n. So this n is basically the remainder. This is basically the remainder when we divide B by A. Okay. So if I do 10, oh, this is not a percentage, by the way. I don't know what is the symbol of in mathematics of mod, but in Python and in computer science we do this percentage symbol. So I'm not really sure. And generally we write B mod A. So this will do, and this is what we use in programming. Okay, so if I write 10 mod 2, this gives us 0 because 10 is an even number. 2 divided by 10 gives us no remainder or 0 remainder. If I do 11 mod 2, this will give us 1. Okay, okay, is it correct? Is it okay?
Yes, sir.
Yeah, and this 0 remainder basically tells that something divides something, like 2 divides 10. And by divides, we mean evenly divide. Basically, the remainder equal to 0. This is essentially what we mean when I say something divides something. Okay?
Yes, sir.
And yeah, let's do prime numbers now. Division is essentially this much only. Okay, there is something known as factors. Factors is in our syllabus. Factors. So factors are essentially what we can say. Factors are chunks of a number. Chunks of a number. Any number can be divided into some chunks of some different chunks, essentially in the pair of twos, two number. Let me tell you what I mean when I say two numbers. Uh, okay. So let's say 12. 12 can be written as 4 times 3. This is one chunk. Or we can do 2 times 6. This is another chunk. We can increase the size, obviously. We can do 2 into 2. This becomes 4 into 3. This is another chunk. Now, notice this chunk. Every number is a prime number. 2, 2, 3. Prime, prime, prime. This is prime. This is not prime. This is not prime. This is prime. But here all numbers are prime. Okay. So these are known as factors, and these are known as prime factors. You guys know the definition of primes, right? Or should I first tell the definition of primes? Okay. I guess I can continue. So the point of making this statement was any number, any arbitrary number, let's say n, can be stated with a multiple, with multiples and with products of prime numbers. Prime numbers. And by the way, this hash mean numbers. So whenever I write hash, this means numbers. Okay. So prime hash means prime number. Any number can be written in its prime factors. And these prime factors come in very handy. This prime factor is has a very good property, very nice property, which is it is unique. It is unique for every number. It is unique for every number. Give me any number. Let's say 15. Let's just say 15 can be written as 3 times 5. This set, if we just ignore the order, like 5 into 3 is equal to 3 into 5. Let's just say order doesn't matter here. Okay, 5 comes first or 3 comes first. This doesn't matter. But notice the numbers: 1 times 5, 1 times 3. This is uniquely associated with 15. This is uniquely associated with 15. There is only one prime factor, a set of prime factor associated with a number, and there is only one set of prime factor which associate with a particular number. Okay?
Yes, sir.
Yeah. And now let's talk about something known as density, about density of rationals. Now, this is a little vague topic, and I don't really think this will come in exams and all, but this topic is very fun. So, this you guys should know about it. This is very fun topic. This is a very fun thing. So, mm, let me draw a number line. This is our good old number line: 0, 1, 2, 3, -1, and -2. And I'm not drawing more. Let's just make dot dot dot, and this will do. Okay. So, this is, let's say, integers number line. Okay. This is integers. Now notice this thing: between any two integers, 1 and 2, there is this space which is empty. This space which is empty between any two integers. I am not talking about rationals or reals here. Okay, I am talking about integers. This space is empty. This space is empty. Basically, I'm saying between any two integers, between any two consecutive integers, I should say, there does not exist an integer in between them. What I'm saying is between any two consecutive integers, this is an integer, this is its consecutive integer. Between these two integers, there does not exist an integer in between them. This is what I'm saying. You got the point? And if I extend this notion to real numbers, rational numbers, rational, oh, wait, let me change my color to black. And if we change this notion to rational numbers, then something cool happens. 0, 1, 2, let's just say. Between any two numbers, let's say 1 and 2, between any two number, it need not to be an integer. Between any two number, I can find another rational number in between them. Can you guys tell me any rational number between these two? Between 1 and 2. Between 1 and 2, give me a rational number between them.
Between 1
Any
and 2,
rational.
we can say 1.3, 1.3 or 1.5 rational number.
Yeah, 1.3, 1. There exist infinitely many. Okay. So, we can take an average between two, and this will return us a value in between them. Okay.
1.5.
It will, yeah, it will not work for zero. Obviously, we can't take 0 and 0. We need to take consecutive or not non-same numbers. Like, let me just explain what I am saying. Take any two rational numbers. Let's say A is a rational number, and let me use some mathematical symbols which will come in handy. This symbol means belongs to. Okay. This symbol of curly E kind of, this means belongs to. Okay. So let a number A, belongs to rational numbers. Rational number symbol is Q. Okay. Let A belong to Q, which means A is a rational number. Okay. let B belong to Q.
Yes, sir.
This is which means B is also a rational number, and A is not equal to B. Okay, this let's take any number satisfying these conditions. The number should be rational and they should not be same. Give me any numbers. Let's take some small numbers. Okay, let's not take very humongously large numbers. Okay, let's take let's take what we can take 1.3, let's just say, and 1.3, and what we can take 1.5, let's say. We have two rational numbers which satisfy this condition. 1.3 is a rational number, 1.5 is a rational number, and they are not the same. Okay, now I can find a rational number between them just by taking their average. Just by taking their average. 1.3 plus 1.5 divided by 2, this gives us 1.4. 1.4 is a rational number which is between them. Now you can do this process infinitely many times and you will get infinitely many rational numbers. The point of stating this fact was between any two numbers in our rational domain, there exists a number. There exists a rational number, which means rational numbers are dense. Between any two numbers, between any point, I can find a number. But this doesn't mean that rational numbers are complete. We There are holes. There are many holes in the line of rational numbers. Of the holes are existing because of irrational numbers, because of number like root 2, root 3, root 5, and irrational numbers. The set of irrational numbers make hole in the line of rational numbers. Okay, irrational numbers occurs in our real world, but are not in our rational line. That is why we need to make real number line after rational number line. Okay, so there are some terminologies associated with these. The terminologies are the number line of integer is discrete. The This number line is discrete, DISC, let's say for short, because between any two there exists no other integers, and the number line of rationals is dense. This is dense because between any two rationals you can find another rational, but this is not the case with integers. And since this is not a case with integers, uh, since this is not a case with integers, since this is not a case with integers, this cannot be a case with naturals as well. And since the property of that what property, the dense property holds with this, dense property holds with this also. Does this make sense?
Yes, sir.
Yeah. Okay. Let me just see if we have some any other topic left for this. Okay, we have complex number, but complex number is not in our syllabus. But let me just tell you the notion of complex numbers. Complex numbers are essentially the numbers like square root of -1 and any multiples of this. Let's just say. So this number does not exist in our real world, and by real world I mean real line. In our real number line, this number does not exist. But if we can write it and if we can square this, and assuming our standard operations, this gives us -1, and this definitely exists. So these type of numbers are known as complex numbers. Okay, they are not in our syllabus. You need to worry about them if you are not comfortable with them. But this is just for your knowledge. Let's just say this doesn't really make a whole lot of difference. And yeah, this is essentially the syllabus of number system. This is what number systems in our week one is being taught. Okay.
Yes, sir.
Yep. Let's wait a minute. You guys have any doubts regarding anything which I taught today? Any doubts? कोई भी doubt?
No, sir, clear.
No, sir.
Okay. Just wait a minute. Okay. Since there is some time left, let me just tell you the notion of sets, and we will continue this in our next class also. So don't worry if you didn't get in this time. Sets. Okay. We will cover this in our next class also, but let's just stick with it. What do you guys understand when I say set? Sets. No mathematical definition. In general, sets. What do you mean by sets?
Sir, set is a collection of items.
Exactly. Set is just a collection of items. Collection of, let's say, objects. Okay. Objects is the most standard term used. Items also work, doesn't matter. Same thing. Collection of objects. Now, these objects can be anything. Anything. Anything you can think of. Your thoughts, maybe. You know, uh, a cap of my pen, a house, a tree, anything can be a object, anything essentially. In mathematics, what we do is we collect objects of some properties which are of interest to us. Okay, like let's just say I'm interested in let's say I'm making some theories regarding even numbers. Let's just say so I am interested in a set of even numbers. I'm interested in this set, 2, 4, 6, 8, dot dot dot. I'm interested in this set. Maybe okay. If I'm doing something if you're doing something different, I'm interested in some other type of set. Let's say set of odd numbers, 1, 3, 5, dot dot dot. I don't really know, but I'm interested in this set also. So sets is essentially group or collection of objects. Here order doesn't matter. Okay, order doesn't matter. If I write, let's say, set of two numbers, 1, 3, this is exactly equal to 3, 1. Order doesn't matter. And by the way, my handwriting is a little weird, but this is this symbol. Okay, the curly braces, but yeah, my handwriting is a little weird here. This is that symbol. Okay, this is sets in essence. Nothing more. Sets is just a collection of objects, nothing more. And there are then some what we know, what we call, there is a notion of finite and infinite set. Like these two are finite sets. It has finite number of elements, which is two in this case, two elements here. This, however, is an infinite set. This has infinitely many elements. We can go on and on, 1, 3, 5, 7, 9, and so on and so forth. This doesn't really end. Okay, so this is the notion of finite and infinite set. And after we know this, we can deduce or we can make a new property or a new thing which is known as a cardinality. Like cardinality is this number, which is known as count. Let's just call it count for now.
Cardinality means
Count.
number of elements.
What?
I was saying cardinality means number of elements in a set.
Exactly. Cardinality means number of elements. And you will see in the next class itself, tomorrow, you will see a very beautiful notion which we can associate with cardinality and infinity. You will see tomorrow. Which is very good. Okay. Okay then. It was just for fun, by the way. This was just for fun. It is. I will teach this in our next class in way more detail, in way more details and whatever the information I should give you. But let me just tell you, this thing is very interesting. It is very very interesting. The concept of cardinality and infinity. Okay, you can. I guess we should wind up now. Number systems is done. Please make sure to take some notes of your own and came it through. It is very easy, but yeah, you should just keep all these things in mind. I will see you guys tomorrow.
Sir, hello.
Yes, yes,
Sir, one doubt I had.
yes, please.
Sir, after this session, today I saw that this session is free. So, mathematics one session for unknown IITians, is it free or cost is there, sir?
Uh,
Fees, how much?
okay. I'm not really sure about the paid and free classes, but yeah, it is paid. Yeah, you can see the supports message in the DMs.
Okay, the class today was only free actually. First day.
Yeah, yeah, I guess.
Okay, okay. Thank you, sir.
Yep. If you guys have any doubt, you can ask me, or you can please tell me your reviews about today's class. If you guys have any suggestions.
Sir, hello.
Yes.
Sir, the lectures for the foundation batch, it is paid,
Mm-hmm.
and uh, I wanted to ask that in YouTube, is it available for free for foundation course?
I'm not really sure. You can. Okay.
Okay. Okay, okay, I understood. And just one more doubt I wanted to ask that suppose a student only watches IIT Madras lecture and does not subscribe to any of the course, any course or any other YouTube video. So what will be disadvantage for that?